So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is your very own mass coder this side. So today's the problem is minimize the difference, and let us not waste time and look at the problem directly. So the problem says that you have been given an array as input. So your array is 1, 2, 3, 4, 5, right? This is your array. Let us name it as ARR. And you have been given a k as 3. You have been given a k as 3. The problem says that from this array you have to delete a sub array whose length, or you can say size, is k, that is 3. So what are the options, like how which sub array can you delete? So you can delete 1 2 3 and the remaining array will become 4 5. You can delete 2 3 4 and the remaining array will become 1 4 1 5, sorry, right? And you can delete 3 4 5 and the remaining array will become 1 2. These are the only possible three cases that you can delete the subarray of size 3, right? Okay, so we know for sure that in an array of size n, if the subarray is of length k, what are the total number of arrays that will be formed? Like what are the total number of subarrays, distinct subarrays that can be formed? That is n minus k plus 1, right? This is for sure. You can see 3. 5 minus 3 is 2, 2 plus 1 is 3. So okay, 3 subarrays obtained. Now, in these subarrays, we have to find this answer, that is, if I find the maximum among these, so maximum is 5, minimum is 4, maximum is 5, minimum is 1, maximum is 2, minimum is 1. So if I subtract them, 5 minus 4 is 1, 5 minus 1 is 4, 5 2 minus 1 is 1. So you can see the minimum difference possible is 1, and that is my answer, right? So you have to give me the minimum difference. You have to give me the minimum difference of the remaining array, minimum difference between maximum and minimum, between maximum and minimum of the remaining array after deleting sub array of size k. I hope that is clear to you, right? I hope the problem is clear to you, that what is the question demanding from you. And let us now look at the approach. So as usual, we will follow the brute force approach. Brute force approach. Now, the question tells me that I have to take the subarray. So my first brute force approach says that take all the subarrays. Take all the subarrays. That is, start from I equals to 0, right? And go up till I equals to, now what will be the ending index? So if I'm taking all the index starting from I, so this is my potential, this is my potential, and this is my potential. These are the three potential subarrays. Here I is 0, I is 1, I is 2, I is 3, I is 4. So my last subarray is forming from 2, that is n minus k in these terms, right? So my I will go up till and equals to n minus k. In this case, my subarray is I up till I plus k minus 1. I up till I plus k minus 1. This is my subarray in this case. Now, I will use another loop. Suppose for j equals to 0 to n minus 1, that is traversing the whole array. And I will make two variables, mini and maxi. Let me write it here. So, my minimum is currently int max, and maximum is currently int min, so that I can use minimum, min and max, that is defined in the STL properly. Now my j will move from 0 to n minus 1 if j is not in the range, this range, I to I plus k minus 1, I to I plus k minus 1. This can be defined easily with the equals to and operators, less than equals to and greater than equals to, the range thing. Then only update your mini and maxi. Then mini will become min of mini and ARRI, and similarly maxi will become maximum of existing maxi and ARRI, right? After this loop ends, I can say, suppose my answer is currently int max, because I have to minimize, so I'm taking the max, right? We always go the opposite side. After this loop ends, my answer will become minimum of existing answer with maxi minus mini, maxi minus mini, right? This is my steps. Any problem, guys? Any problem? What will happen? I will use all the subarrays, and each one subarray is for I to I minus I plus k minus 1. Then I will traverse the whole array, and if that element is not in the current subarray, I will use the mini and maxi, and after this loop ends, I will update my answer according to this operation, and I will get my answer. Now, what is the time complexity? Very evident, very evident. It is moving n minus k times, and it is moving n times. So what is the time complexity? It is n minus k into n minus k into n. So supposedly n square times, right? Very big, very big. What can I do? I can make the approach efficient. I can make the approach efficient. How can I make the approach efficient? So efficient approach. Efficient approach says that I have my array as 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So please pull back your sources because the efficient approach is gonna be long, and the optimized approach is actually shorter than the efficient approach. But you have to understand what is happening in the efficient approach also, right? Because you have to make the interviewer understand your point of view. Okay, I say put the whole element into a set. Okay, you put all elements into the set. So 1, 2, 3, 4, 5. This is my set right now, right? And also create a frequency map. So my MP right now contains 1 map to 1, 2 map to 1, 3 map to 1, 4 map to 1, 5 map to 1, right? This is my current map. This is my current frequency map. Now I will use the concept of sliding window. How will I use? Just see. I will keep my start pointer here. I will keep my end pointer here, right? Now I am deleting the first subarray, that is from 0 to k minus 1. That is the length k subarray of that will be the first subarray, right? 0 to k minus 1. In this case it will be 1 2 3, right? What I will do is I will move my end up till k minus 1. So while end is less than equals to k minus 1, what will I do? As I move my end, I will remove the elements from the map. I will remove the elements from the map, and as soon as any frequency becomes 0, I will remove that element from the set also. What I'm saying is I will remove, or I will say decrease, the count of element from map, right? And then if frequency of that particular element becomes 0, I will remove it from set also. Becomes 0, remove it from set. So what is set saying? Set is keeping how many elements are present in the current subarray after deleting the subarray, right? After how many elements are present in the array after deleting the subarray. Set is a count of that. Okay, so what I will do is I will say MP of let us say the array is A. So MP of A of end minus minus, and then if MP of A of end equals to 0, in that case set dot remove. So st dot remove, suppose this is my st not s, right? So st dot remove that element, that is A of end. After removal, suppose that, like I have deleted my first subarray currently, I have deleted this element. So what will my this look like? This will be 0 0 0, and these all will be removed. Then I will use my loop to do the sliding window concept. So while end is less than n, so that my end will go up till 5. That is the last subarray. The subarray which will be ending at 5, that will be the last subarray that is possible from the given array, right? Okay, what I will say is for each subarray, suppose you have deleted this in the first step. Now the elements remaining with you are 4 and 5. The set also contains 4 and 5. The set also contains 4 and 5, right? So what I will do is I will use the s. I will say for auto it in s, for auto it in s, that is that element is present. I will keep a minimum and maximum here. So mini is currently same int min int max, and my maxi is equals to int min, right? Solved. After this I will say same mini equals to mini equals to minimum of mini and it, and similarly maxi equals to maximum of maxi comma it, right? And after that what I will say is, I will update my answer, right? After this loop I will update my answer, so my answer becomes minimum of answer comma maxi minus mini, right? This loop will work on. And when I will move my start pointer, this loop is something like here, and this loop is not ending right now. Let me change it. Yeah, yes, after this loop, after this step I will have to update my start pointer and my end pointer. So what I will do is, I will move my s pointer forward, and before moving I will add this element again, because now after this subarray, now my new window will become 2 3 4, right? So my s is coming here, but before moving s here I will add this element into the map as well as the set. So what I will say is, I will say mp of s plus plus, all right, mp of s plus plus, mp of a of s, sorry, a of s, that is a start. Okay, and if mp of a of s equals to 1, that is that this element is new in the subarray, I will say st dot insert a of s. And similarly for the end, because I'm moving end forward, because I'm moving uh, my end was currently here, I'm moving end here, I will have to delete this, element, right? So what I will say end plus, after this s plus plus start plus plus, and I will say end plus plus, and after end plus plus I will say delete that element. So delete that element. So using this only, right? The same loop. So what is the time complexity now? So previously we were using O of n just for the outer loop, just to get all the subarrays. Now we are just using that O of n for start and end points, right? We are not traversing again and again, and again. And this thing can be compromised by using the set property of the maximum and minimum. The set property of maximum and minimum, and that can be converted to L log n, and my answer will become O of n log n with a space complexity of O of n, because I'm using a map and a set, right? So this should be clear to you right now, right? Any problem? Any problem, guys? What are we doing? We're keeping a sliding window concept with a map and a set. Map is calculating my frequency after deleting the current subarray, and set is keeping the array elements which are in the subarray, which are in the remaining array after deleting the subarray. Okay, okay. Any problem? Are we on the same page, guys? Are we on the same page? If any questions, please, with the timestamp, write down in the comment section. I will surely get back to you, right? And it's time to move to the optimized approach, the most easiest approach, I will say, the most easiest approach, right? The today's question was actually a brain buster for me also. Optimized approach, right? But previously I have solved it, so I know how to solve it. Like in the first I was also not able to solve it, but previously, like 2 to 3 months ago, I have solved this problem. So this was just a revision for me, right? So my array is 1, 2, 3, 4, 5. Now try and understand my point. Try and understand my point. Suppose I'm deleting this subarray. I'm deleting this subarray. I only want to minimize difference between maximum and minimum. That is what I want. That is what I want. So I just want maximum and minimum. I just want maximum and minimum in the remaining subarray. In the remaining subarray. Is that achievable? Is that achievable somehow? Is that achievable somehow? So suppose I create two arrays. I create two arrays. One is known as post max, another is known as post min, right? Post max contains maximum element at index greater than equals to I, and similarly post min contains minimum element at index greater than equals to I. What I'm saying is maximum element at index greater than equals to I. So for the remaining element, you can see for 1, what is the element which is maximum, but after this, not before this. So you can say 1, 2, 3, 4, 5. 5 is the maximum present. 5. For 2, again 5. For 3, again 5. For 4, again 5. For 5, again 5. Why 5 for 5? Because I'm using equals to also. Right? And similarly, what is the post min? So after 1, what is the smallest element present? So for 1, it is 1. For 2 is 2, 3, 4, 5. No doubt, guys, no doubt. So this is my post max and this is my post min. Right. Now, I am saying that my array is currently 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What is my first subarray? This is my first subarray. My remaining elements are 4 and 5. My remaining elements are 4 and 5. So, what is the indexes? It is 0. Let me change the ink. 0, 1, 2, 3, 4. My n is 5. My k is 3. So my first subarray is from 0 to k minus 1. You can see 0 to 2, 0 to k minus 1. I have deleted this element. Now I have got remaining elements and 4 as 5 and 4 as 5. So I can say, can I say, just listen to me, can I say the maximum element and the minimum element after this in this subarray is actually this? Try and understand what I'm saying. I am saying after deleting this subarray in the remaining after deleting this subarray in the remaining array, maximum and minimum elements for these remaining elements is actually this mentioned here. Okay. So this is my first operation. My first operation says I initialize my answer by using post max of k, because my k minus 1 is getting deleted. I have to start with k. K is equal to 3 here, right? Minus post min of k. Okay, this is my initial answer. That I am getting anything lesser than this, but no questions arise that I am getting anything greater than this, because this is achievable. This is achievable. Okay. Now let us take the another case. So my array is 1, 2, 3, 4, 5. Suppose I am deleting the subarray 2, 3, 4 here. 2, 3, 4. Now I said you that is it possible to take this element as maximum and minimum? Is it possible to take this? You will say no, because we have to account for this also. We have to account for this also. Okay. So we have to come up with a way to figure out the previous elements also and the next elements. The previous and the next. The previous and the next are available to me with the help of this. Right? So I just want the minimum and maximum among these. Minimum and maximum among these. I just want minimum and maximum among these and minimum and maximum among these. This is my demand, right? So just see my approach, what I'm saying, right? I have initialized my answer as post max of k minus post min of k. I will take two variables. I will take two variables, name it as maxi and min. Now, just because I have accounted my answer for the first subarray, I have accounted my answer for the first subarray, my second subarray is going to start with 2, 3, 4. 2, 3, 4. Right? What is the previous for 2, 3, 4? Only this 0. Only this 0. So what I will say, my maxi is also ARR 0. My mini is also ARR 0. My maxi is also ARR 0. My mini is also ARR 0. No problem in that. No problem in that. My maxi is also ARR 0. My mini is also ARR 0. Now what I will say, I will run a loop using I going from 1, and what is the maximum I can go? I can go, like I is marking the starting of the subarray. So we discussed that I can be 0, I can be 1, I can be 2, I can be 2, right? I can be 2, that is n minus k. I can go up till n minus k, 5 minus 3, that is the last subarray that is possible. So I is going up till n minus k. That is the last index, right? I am saying that leave the last subarray for a minute. Leave the last subarray for a minute and go up till n minus k minus 1 only. N minus k minus 1. For these subarrays, can I clearly say that my answer will be minimum, because I have to minimize of the existing sub answer, and and I will take the max of this maxi, because this is the previous, and the post max of I plus k. Post max of I plus k. This is my maxi. This is my maximum. And minus minimum of current mini and post min of I plus k. If you're not able to understand, just give me a minute. I'm coming back to you only, right? So what is happening at this step? Answer is getting updated because you have to minimize it. So I'm taking the use of min. I'm taking the reference of it. Now this expression, what is happening in this expression? So for 2 3 4, for 2 3 4, one is my maxi, one is my mini, and I plus k. So what I'm saying is my I is currently here, I plus k, I plus k is here, that is at 5. So this post max and post mini will give me the maximum and minimum for this, and maxi and minimi are giving me the maximum and minimum in the previous subarray. Any problem, guys? Any problem? So what I'm saying is post max and post min is giving me the value for this, and pre max and pre min, that is maxi and mini, are giving me the value for this one. Nothing problem. Okay. After this updation, my I will move here in the next step, right? But before my I moves, I will have to update my max and minimize. I will have to update my max and mini, right? So what I will say maxi will become max of existing maxi, ARRI. Mini will become maximum or minimum of existing mini and ARRI, right? Now, after this loop, all the subarrays taking from this up till this, only the last subarray will be left. Only the last subarray will be left. Why didn't I got to you, like, why didn't I show you the exact code for the last? Like, why didn't I extend this loop to n minus k? For this, the reason is I plus k. I plus k for n minus k, like I plus k is n minus k plus k, that is n. N will be out of bounds. So I will handle that easily. So for 3, 4, 5, what is the only possible thing? That is the previous subarray. So I will just say answer equals to minimum of existing answer with maxi minus mini. Understood? Understood? And after that, I will return my answer. So what I'm doing is I'm just keeping an account for the post max and post min. Also, I forgot to tell you how to make the post max and post min. Let us discuss that also. So my array is 1, 2, 3, 4, 5. Right? I want the array at post mix. So for it is significant that post max and post min for 5 is always 5. That I will define it by own. So 5, 5. And now for this, post max will be maximum of this or this. So it will be 5 again. This or this, 5 again. This or this, 5 again. And similarly for min, it will be minimum of this or this. So it will be 4, 3, 2, 1, right? And it will be 5. So what is the loop? For post max, I am using for I equals to n minus 2 up till 0. That is, I am using a decrementing loop, and I will say post max of I is equals to max of ARRI with post max of I plus 1. And similarly, post min of I is equals to minimum of the current element at ith index with post min of I plus 1. Any problem, guys? Are you able to understand it? Are you able to understand it? Are we on the same page? Okay. So it's time to move on to the code. I hope you understood the video. I hope the approach I was trying to tell you, right? And any problem, you know where to comment. You know where to connect with me, right? And also, guys, I'm seeing that lot of less of you are connected with me in the Instagram or LinkedIn. So please follow me. Please connect me with me and ask doubts, right? Explore. Okay. So let us move to the coding area. So without wasting your time, let us try to find the answer using the code. So first I will create the post max and post min, right? Size will be n, starting with all the elements are 0. So vector of int post min of n comma 0. Now the last element of both are same, that is last element of the array. So post max of n minus 1 is equals to ARR of n minus 1. And similarly post min of n minus 1 is equals to ARR of n minus 1. Now we are making our answer as int answer equals to using the kth element of the post max and the post min. That will be post max of k minus post min of k, right? And we are declaring our maxi equals to ARR 0, and similarly mini equals to ARR 0, because for the second subarray the previous elements only consist of the first element, right? And now we will make our loop go from I equals to 1 up till n minus k minus 1. I plus plus answer equals to min of existing answer with max of post max of I plus k, comma maxi minus min of post min of I plus k, comma mini, right? Mini. And after that update your maxi and mini. So maxi will become max of ARRI with maxi, and mini will become min of ARRI with min, right? And it will be mini here. And for the last subarray, the only previous and post are the only maximum and minima are from the maxi and mini. So I will say answer equals to min of answer with maxi minus mini difference, and I will say return your answer. This code should run fine, and let us try to compile it now. In the meantime, I would request you to hit the subscribe button, and if you hit the like button. So there has been some mistake. Oh, the mistake has been we have not defined the post max and post min, right? So what I will say, for int I equals to n minus 2. Let me zoom it in a little. I is greater than equals to 0, I minus minus. Post max of I will become maximum of ARRI with post max of I plus 1. And similarly, this is the same for post min, but using the min. So min, 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 right? Let us try to compile and run it now. I hope it will work fine, and it is working fine. Let's try it for submit also. In the meantime, I would request you, if you are new here, do not forget to subscribe my channel and hit the like button as much as possible. Thank you guys for watching the video, and you can see it is a 123-day streak. Thank you for all your love, and we'll meet tomorrow with a new question and a new energy. Bye. Have a nice day.